So now practical application. So this is your actual robot. So chassis and drivetrain, there's a couple important features we think every chassis and drivetrain should have. A stiff and stable frame. So FTC game, it's high contact. You're not allowed to hit people or things like that, but robots will hit each other, there will be pushing, and especially during an autonomous period where you can't back off, you're not in control. You're not in manual control of it. So you want a frame that's not going to fall apart during the match. That's kind of obvious. Maneuverability. So you want to have a robot that can get where you need it to go when you want it to. So this depends on how your frame is. Most like four-wheel robots are usually pretty maneuverable and they can turn. But for us, we like to build a six-wheel robot tank drive. But the problem with that is there's a lot of friction when you're turning. So ours it's called drop center, or we create a rocker basically. So what that does is it creates a fulcrum in the center of the robot so you can turn easier. And you do that by either making the center wheels a bit lower than the outside ones, or you give them a bigger diameter. Additionally, something you can do is omni wheels. You guys all know what omni wheels are? Probably, yes. Okay, yeah, so omni wheels, you can put them, if you have a robot with a lot of wheels, you can put them on the corners or at one end to make turning a little easier and to reduce scrubbing.
That's an omni wheel. Right here.
So, you want to find the right balance of speed and power. That's another big thing. So this really depends on your game analysis and after you analyze the game when you're building the chassis. So for example, during the Ring It Up season, all of the robots were concentrated in a small area for scoring, and there was a lot of heavy contact, so you wanted a frame that had a lot more power to it. That way you couldn't get pushed around or out of the way. On the other side of the coin, during the block party season, there was a lot of movement and defense was much harder. So you wanted a robot that could quickly move back and forth, and like someone mentioned earlier, you wanted high cycles. So you wanted to be able to pick up blocks, score, pick up blocks, score really quickly. So a slow robot wouldn't be scoring very many points with blocks. And finally, practice driving before a tournament. This is probably one of the #1 advice we can give, especially like rookie teams. I know you want to work on the robot to the last second and get it perfect, but you always, before your tournament, want to block out at least some time to practicing driving the robot. Because even if your robot's great, if you can't accurately drive it and you're hitting walls or your partners or getting penalties, you're not going to win. So you want to be prepared for all parts of the field, and like we talked about the far side, get practice with that so you don't have to rely on someone else who has practiced that to score for you. A couple other points about your chassis and drivetrain. You want to isolate your motors from impacts. So basically this means you don't want to leave your motors exposed where they can get hit around during heavy contact, because it'll basically ruin them. Another point is your traction should be less than torque. So what this means is when you encounter something like a wall that you can't move, you don't want to have more traction than torque, because that means your wheels will stall and they're not going to turn. You want to have your wheels that are able, if your robot hits something you can't move, they'll spin out basically. And
How do you test that?
How do you test that? We push it against the wall, basically. We put a robot next to the wall and just drive it into it, and if the wheels don't spin, there's a problem. Yeah.
What do you do to change this?
Huh?
What do you do to change it?
Well, yeah, it's a lot. So for traction, a lot of things that matter is the type of tread you have, or type of wheels, your weight, and then you can also change the drivetrain. So what ratio it is, how many motors are on the drivetrain. It really has to do with what your goals are for that chassis.
One thing that we did in autonomous is the gearbox would automatically shift down into low gear. That way we'd have more torque and be able to spin out, push through whatever we need.
Because if something happened in autonomous and we got stuck or in a corner or something. Mechanical alignment, if you did FLL, this was a big thing in FLL too. Mechanical alignment means you use some part of the field basically to line your robot up against every time. So during autonomous, this is more important because this way it's solid, it's more reliable. So you'll be more accurate and you won't have to rely as much on blind programming or sensors basically.
So like a good example of mechanical alignment is when you're going in for a handshake and you see this is our alignment. We're not just blindly going in and grabbing like this. We can go in, we align here, after the hand mechanical line.
And then programming the knowns is another reliability and consistency kind of deal. So what you want to do after you've analyzed the games and you know how you're going to be scoring, you don't want to be manually moving everything. So for example, during the Bring It Up season, there was a rack where you scored donuts basically in a tic-tac-toe pattern. So these were preset heights that were the same at every tournament. So rather than me manually moving this thing up and down, I could hit one button and it would go to the height I needed. So that saved a lot of time and it was more accurate. Picking up blocks was another thing during the block party season. You want to have something that will scoop them up the same every time rather than you trying to aim it and then lift it and all that.
Especially if you have a complicated tool with multiple joints. So like for our block scoops, we had the wrist and the shoulder, and we could turn back and forth. So we just had, and the hand that could close. So with our pickup routine would go down, we drive forward a little bit, grab, pull back, and shake, and let go, and then grab again. And so that was all just one button press. That way we could get a consistent pickup routine.
And finally, you want to keep your limitations in mind. So especially for rookie teams, the maximum is 8 motors, 3 Lego motors, and 12 servos. Well, it's not 12 servos anymore.
Yeah, it is.
Oh, it is 12 servos? Oh, okay. What is it? It's 5 amps.
Yeah, we'll get to that.
We'll get
later. 12 servos.
8 DC motors. So, but teams know this, but really what you want to make sure is you're designing with those limitations in mind. So you want to spec out basically where those 8 motors are going to go. So you're not designing something and then you realize, oh wait, we have 6 motors on our drivetrain and 2 doing this. Now we don't have anything to spin the flag or something like that. So you want to keep that in mind when you're designing so you don't have to go back and remove motors.
And you also, it's important to consider the power that they have. So if you can use a Lego motor in an application and have the similar performance to using a DC motor, you're going to want to use that Lego motor because your DC motors are more valuable.
How many motors would you recommend you use?
All 8.
Okay.
Tidbits. So checklists. We have a checklist on the body of our robot for a consistent setup at the start of every match. We'll go through each number on the checklist to make sure that our robot's set up the same way every time, or else we're going to forget something. We also have a checklist in the pit for between matches. That just makes sure that we have a consistent maintenance routine we go through, and they're listed by the level of importance. The red is the most important, and then it goes down from there.
Well, something we do that a lot of teams don't do is rather than waiting for something to break, we make sure it doesn't break in the first place. So after every match, even practice matches, we take the robot back and we check, using this checklist, we check over everything. We make sure set screws are tight in, wires are in place. And this way you don't have to wait for it to catastrophically fail and then realize, oh, we need to maintenance this. It'll make it more reliable, basically.
We also have a checklist that I carry on my clipboard as a coach, and I make sure because they're the main people who are going to be driving the robot, so they know the main strategy. So they're going to be talking to the teams that we're with. So it's my responsibility to make sure that everything's tightened and like they said, and also when we go back to the pit that we reset everything.
And in fact, in FLL, they changed the rule in 2008. Some team was questioning why the Cougars were bringing a piece of paper to the field when it was our checklist for the start of the match. So first it was like, hey, that's a good idea, and then they made that allowed.